This video discusses one problem involving Charles' law. So what's Charles' law? Charles' law stated that at constant pressure, the volume is directly proportional to temperature. Meaning, as temperature increases, volume increases. Or as volume increases, temperature also increases. So meaning they are directly proportional to each other. So similar to Boyle's law, we will introduce a proportionality constant K to get rid of the proportionality symbol. So by isolating K, we have V divided by T equals K. So again, at any condition, V1 over T1, so this is your initial volume and initial temperature equals K. And this is our final volume and our final temperature equals K. So, our working equation is V2 over T2 equals V1 over T1, or simply V1 over T1 equals V2 over T2. However, there's an important note that you have to always remember. The temperature here is absolute temperature. So, meaning you always have to express your temperature in Kelvin. Okay, so again, you always have to express your temperature in Kelvin. So for our first problem, the volume of a gas is 23 liters at 42 degrees Celsius. What should be the temperature to decrease the volume to 18 liters? So our given required will be, so since this is Charles' law, so we have constant pressure. So the variables involved are V1, T1, V2, T2. So V1 is 23 liters. T1 is 42 degrees Celsius. However, again, you have to make sure that your temperature is in Kelvin. So we will add 273 for our temperature to be Kelvin. And our V2 is 18 liters. So T2 is our unknown. So our working equation is Charles's law. So V1 over T1 equals V2 over T2. Alright? So let's now start our solution. So again, this is just substitution. So our solution would be V1 over T1 equals V2 over T2. So that would be 23 liters over 42 plus 273 is 315 equals 18 liters over T2. Liters cancel. So your T2 will be in Kelvin. So that would be 315. I'll show you the solution. So that would be 23 T2 equals 18 times 315. So T2 equals 18 times 315 divided by 23. So are we expecting a higher temperature or a lower temperature? Yes, we're expecting a lower temperature because our volume decreases. So our T2 would be 246.5 to Kelvin. However, it's better if we will express our answer in degrees Celsius. Again, you only use Kelvin if you are substituting to the equation. But if you are to express temperatures, it could be Celsius, Fahrenheit. But whenever you are using this equation, the temperature should always be in Kelvin. So our T2 would be 246 minus 273. So our temperature will be negative 26 degrees Celsius. So as I have mentioned, we are expecting a lower temperature, which is negative 26. That is way lower than 42. So this is our final answer.